This is linear graphs, and so linear means straight line graphs. And we'll just read through. A linear graph is one which is formed from a linear function, i.e. one of the form y equals mx plus c. X and y are variables. M is the gradient of the graph and c is the y-intercept where the line goes through the y-axis. When we are drawing graphs, we draw up a table for x and y, plot the set of coordinates x and y on the graph and join them with a straight line, or find m and c. Plot c, use m to plot two more points, and then join them in a straight line. So we're going to go for the table method just for this one, a wee bit more about y equals mx plus c a little bit later. So we do a wee table of values for x and y, just to keep things nice and straightforward. So that would be x, that would be y, and if I look along here, these are the values I'm going to be putting in for x, so I'm just going to pick some of these ones really. Some of them really mightn't fit, so I'll maybe just go -2, -1, 1, 2, 3, let's go in fact -3, -2, -1, 0, 1, 2. I fear it won't fit on this graph very well, but we'll see how we get on. I exchange then my x for a -3. 3 times -3 gives me -9 plus 7. Sorry, -9 plus 2 gives me -7. Sub in -2. 3 times -2 is -6 plus 2. -4. Substitute in -1. 3 times -1 is -3 plus 2 is -1. If I substitute in 0, I get 2. Substitute 1, I get 5. And substitute in 2, I get 8. So you can see not too many of the points are going to fit on, but we'll draw what we can anyway. So -3 and -7, we're not going to fit it, it'll be down there somewhere, just kind of down below. -2, -4 is going to fit on. -1, -1. 0 across 2 up. 1 across 5 up. And that then would be our graph there. So if I join these up, with a nice straight line. Let's make it work. And that's the line y equals 3x plus 2. So hopefully that makes sense. You can do it with y equals mx plus c. We'll maybe come back to that a little bit later on in one of the further videos. It is a quicker method. Let's take a wee look then at example 2. Draw a straight line of 1 minus 2x for x values from -3 to 4. So looking at this scale here, I'm going to go 2 for each one. So I'm going to go with 0 here, and then 1, 2, 3, 4, -1, -2, -3, -4, and then I'll just keep the scale the same. It helps you to see the gradient. 2, 3, 4, 5. Of course, that's our y-axis. That's our x-axis, and then -1, -2, -3, -4, -5. You can't see that, but that's okay. Again, our table method. So let's get a wee table drawn up here. Fair few to do, so we will get rattling. X and y, -3, -2, -1, 0, 1, 2, 3, 4, and substitute in then these numbers. So 1 minus 2x, so I'm subbing in -3. -2 times -3 gives me 6, so that then would be 7. If I substitute in -2, this turns into a 4, so it's going to be 5. Substitute in -1, I'm going to get 3. Substitute in 0, I get 1. Substitute in 1 is -1. Substitute in 2, -3. Substitute in 3, -5. And then -7. So if I start to plot that, the point -3, 7 would be up here. The point -2, 5 is going to be here. -1, 3. 0, 1. 1, -1. 2, -3. And then 3, -5. Annoyingly, I can't find my ruler, so I'm going to have to do this in bits, but that will be okay. So a nice straight line going from there. And again, the name of that line, so let's write it on here somewhere. It's the line y equals 1 minus 2x